we have discussed these IoT research challenges where researchers have continuously contributing their work. So still many of the points or the problems will be there in IoT, and we are continuously working. We need to find out the solutions for each and every problem, and these are the very well known and very popular kind of challenges are there. So as I mentioned earlier also, you can select any kind of the topics or these challenges, and you can work on the solution of it, and that would be considered as your B final year project. And there are varieties of IoT different companies will be looking towards the solution of these challenges, isn't it? Now we have discussed all these things. Now today we're going to highlight and see some practical aspects of an IoT. So there are certain familiar results or applications are there. You might be aware about all these applications. They are already implemented. The very first one, the building and home automation. So very widely used, as we are aware about how we can do our home automation, how we can operate any devices remotely if the destination system is not available in your coverage of your devices, but it can be connected to the internet. Once the devices are connected to the internet, we can operate it, we can monitor it, we can get the responses from the devices. Okay, so everything can be possible, and that we have also discussed in your practical sessions also, how we can automate the things if certain event is occurred, if certain actions have performed. Take an example of your temperature monitoring. Now if temperature increases up to certain level, and if it crosses the thresholding value, then what it happens, we can automate any things. So if temperature rises above suppose 40 degrees centigrade, so automatically your fans will be on, AC will be on, it will open your windows, everything. Okay, so depends on any kind of event, we can actuate anything. Okay, and that can be done with the help of IoT platforms. So we can use certain clouds to take the decisions, or certain devices, they can take the decisions locally also, isn't it? But we are totally here dealing with the cloud, how we can take the decisions based on the clouds. Next application is related with the manufacturing. Varieties of industries are working on different manufacturing units or development of certain products. So how this particular IoT can help to monitor the what you can say, the manufacturing of any kind of product, isn't it? So it will be very much helpful for them. Okay, so we can have the I square OT, that is IIoT, Industrial Internet of Things, where devices can be monitored, where devices can be sending the data or communicating with each other via internet. Okay, so that is again a very much trending topic of IoT, that is industrial IoT. Next one, we can have our emergency services, that is in the form of medical as well as healthcare system, and which will be at the highest priority deal. So can we design certain systems so that they'll be going to continuously monitor the real-time parameters regarding the health issues? And can we find out certain solutions by monitoring these particular parameters? So varieties of clouds can be used. Doctors will get the notification about the parameters of the patient on their mobile phones, and they can provide the solution there itself. Okay, and again the next one is the media. The media is very much, currently we are talking about the social media, how IoT can plays a very vital role to manage the medias on the internet. Next one, we are dealing with the environmental monitoring, how we can monitor varieties of environmental parameters, such as varieties of gases are there in the air. If I'm talking about the pollution, if I'm talking about suppose an example of carbon monoxide, okay, or CO2, the percentile in air. If it increases, it will give a problem with the humans. Okay, so how we can going to monitor such environmental parameters, and how we can provide the solutions. Okay, next is the infrastructure management, how we can manage the infrastructure. Let me tell you one thing, how IoT was come into the existence. In a foreign country, I think the name was stated as in Sydney, there was incident happen, and there was a big what you can say, the bridge was there, and there was a huge crowd on, or traffic jammed on that particular bridge, and because of the overload, that bridge collapses. Okay, so many scientists were thinking about why don't we get that particular information about the load on that particular bridge. If the load of that particular vehicles on the bridge will exceed up to certain thresholding value, why could not get that particular information earlier? Okay, means before the incident happened. So they were thought about, why don't we measure or monitor the load of each and every pillar on the bridges, and they will be using different kinds of IoT development boards, and they will be communicating with each other and sending the real-time load parameters of the bridges to the now the researchers. And now the device, not only the devices will take the action, but also if it crosses certain values, automatically that information will be sent, that in the form of notification, and based on that you can predict the things, and we can avoid such kind of incidents also. So in that kind of thing, infrastructure management, how we can manage the loads of an infrastructure, and all these things can be done with the help of this particular application. Next is the energy management. As we are aware about, energy is a very important source. Everywhere we needed energy. Okay, so how we are going to manage it? We are talking about your smart grid technology. How we are going to monitor the load of your electricity. How it can be measured with the different parameters. How we can pay the bills online, everything, how we can automate it. In Mumbai also we are having one kind of system where the current real time readings will be accessible by the users on their mobile phones. So varieties of PLCs were used, and that is a kind of industrial IoT. With the PLCs in association with the IoT, the system will be formed, and automatically the readings will be fetched, and that can be observed on the user mobile phone. Okay, currently in our Pune that system is not available. The energy, the MSAB office, these are certain technicians will come, take the photographs, and they will take it. So that is kind of manual kind of thing. How we can make them automated? So we can simply create our own smart energy meters, so that energy meters can be able to send the real time reading of that individual onto the cloud, and automatically billing calculations and everything will be automated and done, and at every instant of time user can monitor the kind of energy usage on their mobile phones with the help of an appropriate mobile app, that is Android application. Okay, that is a very again trending kind of application in IoT regarding the energy management. The next one we can say is the kind of transportation. Whenever I'm talking about the transportation, now if we are moving towards a smart city, the very important aspect is nothing but your transportation. How we can make the transportation automated. Suppose I want to go to the specific destination. Initially I should get the real-time information of any kind of suppose buses or cars, okay, on my mobile phone, just like an Uber or Ola. They have implemented their particular the plan onto the cloud, so we can real-timely monitor where actually the location of the current vehicle, and based on that the vehicle can talk to each other and take the decisions. And now if we can have this particular smart transportation concept, you will never observing the accidents in the future. Okay, because what happened, every vehicles, intelligent vehicle or automated vehicles, are directly connected or talking to each other with the help of certain technologies. Take an example of your mobile towers or satellite communication. Okay, why are these satellites? They'll be talking to each other, means they are sending and receiving the data, and based on that they'll be coming to know how many devices are nearby to it, and they will be controlling their speeds, and the actions will be taken accordingly. Means every transportation vehicles in a transportation will be smart enough to take the actions accordingly by their own, isn't it? So these kind of applications can be done, and if I'm saying that, you name it and you'll be have in an IoT. You can simply take any kind of example, anyone, and you can create that or design that particular experiment with the help of IoT. Okay, so we'll be observing IoT in everywhere. Okay, these are certain applications of the IoT. Now we are focusing some applications regarding to agricultural, because India is totally based on the agriculture kind of domain. So our main focus should be on agriculture field, how we can do the advancement in agriculture, because again, if I'm talking about the agriculture in India, it is somewhat outdated. There will be no the farmers, they will never accept the new technologies because of the payment issues. Okay, so we want to develop certain instruments those are affordable to them. So can we develop such applications? Okay, so with the help of IoT, so by sitting, the farmers can sit by at their home and they can monitor the content from their farms, isn't it? In or they can operate the contents. So uh, the very first thing I'm talking about, the smart irrigation system. Traditionally, what was the way of starting the or watering, giving the irrigating for the farm? Simply, the farmer can go to their farms and they can start the motor. Okay, but later on, with the help of DTMF, with the help of mobile phones, they will be operating it. In the same concept, why don't we interface certain sensors to your IoT development board, and that can be implemented and integrated into your farm? Okay, and with the help of soil, take an example of a soil moisture sensor. It will be continuously monitor the moisture in a soil, and if it goes beyond certain ranges, thresholding values, automatically the irrigation or the watering can be started. Okay, in this way the decisions can be taken automatically with the help of any IoT platform, isn't it? IFTTT is again one of the popular name. Please remember it, IFTTT. Okay, if this then that. Okay, if this is happen, if soil moisture goes below, then that would be happen, means automatically watering will be given. So in this way you can design any kind of content with the help of IFTTT cloud. It is open source, you can use it in your B projects as well. Okay, IFTTT, if this then that. I'll be showing it in your practical sessions also, how you can easily implement and take the decisions also. Okay, next is a crop water management. So based on what kind of crop or yield in that particular yield, so that can be taken or monitored first, and based on that particular situation, what is the crop period? Okay, how much amount of water is needed in quarterly basis or in yearly basis, depends on some. Take an example of sugarcane. Okay, sugarcane requires more amount of water, okay, as compared to the other crops. So how you can automate it, how you can manage the watering also based on the kind of crop. So initially, if I want to find out what kind of crop is there, so I need to interface the DIP, that is digital image processing, to the IoT. Means I need to monitor it, means I need to identify what kind of crop is this with the help of digital image processing technology, and that I can integrate with IoT technology. So we need to use varieties of different domains with the help of IoTs. Okay, I can connect machine learning algorithms also. I can use or connect your artificial intelligence also, DIP also, signal processing also, varieties of communication also, varieties of domain can be connected to the IoT, and it will be performing a specific task over there, isn't it? Now that is kind of a crop water management system. Next, if we are having a specific yield or a particular crops in a fields, how we can provide the pesticides, that is the pesticide management. During what periods the pesticides needs to be applied. Okay, so that kind of integrated pest management can be done with the help of your IoT technology. Next, we can have the sensor based field and resource mapping. Now, what is the importance of sensors? Because as I mentioned earlier, without sensors, IoT will not be work properly, as the as these variety of sensors provides a sensory vision to the IoT, and without getting the raw data from the physical environment, IoT will not take any kind of decisions. Okay, so sensor based field and resource mapping, so that can be done with the help of this IoT technology. I'll be showing one example also regarding this the field and resource mapping. Next is a remote equipment monitoring. Now, this is a kind of what you can say, what is the status of your remote device? That is a kind of whether the destination device is currently in off state or currently in on state, and how we can monitor it. Okay, so by sending certain commands to it, we can actuate it, or we can see the status of destination system. Okay, any devices can be monitored with the help of IoT technology. And finally, the very important, the predictive analysis of crops and livestock. Okay, so the crops, the analysis, we can do the analysis, because if we are taking the what you can say, we are having a certain kinds of aspects regarding which crop can be taken over which period of the time, isn't it? So we can do that particular analysis with the help of, if you taking these particular crops over the period of years, we will be getting the prior information also from the cloud, and based on that we can do varieties of analytics, whether I can give this particular crop or take these particular crops in this particular time duration or not. Everything can be done with the help of analytics, isn't it? And we can also having take an example, it is not here mentioned, we are talking about the stock exchange also, isn't it, where the importance of the what you can say, the values plays a very vital role, isn't it? Your stock will be going up or down. Okay, and we need to sell and buy that particular stock value. Okay, so it plays a very vital role. In a fraction of second, data should be transmitted from one destination to the another destination. Okay, so varieties of hackers are also trying to invent or integrate varieties of attacks onto these particular servers of stock exchanges. Okay, that is again one of these region where we can walk into, isn't it? Now, these are the certain applications of an IoT. I have shown here one specific example regarding the agriculture, how we can monitor it, how we can automate it, what are the sensors required, it, what are the hardware platforms are required. Now let us see in agriculture using IoT what we needed here. Now see, we can have one a photo where farmer is going to monitor the data. Actually depends on what kind of sensors they have integrated or used in their farm. Okay, so very first thing, they wants to know the crop and soil monitoring. Okay, the content of the soil, it can be measured. Take an example of kind of pH level of a soil. Okay, whether it can nurture the plants or not. Okay, what is needed, everything can be monitored. Next, the weather monitoring. Here a specific device is installed here, and it will be continuously monitoring the weather, whether it's currently rainy season or the about to rain, or a very what you can say, we can have the high wind also, the air monitoring. Everything will be considered, and that data will be here available and stored onto the cloud or the server. Okay, so cloud plays a very vital role, and from the cloud, the devices or any handheld devices from the farmer can able to access such kind of real-time data. Okay, so what we needed, we need to install the varieties of IoT developed sensor nodes, which will be interfaced with varieties of sensors, and real timely every data can be monitored. Not only that, but also you can take certain decisions based on the data we received it. Okay, Now, very popularly, we can have varieties of wearable technologies coming in market very fastly and very regularly. Okay, we can have very simple example of your health bands, your smart watches. They'll be monitor your health parameters such as your temperature of one body, the blood pressure, okay, and how much uh, steps you walk daily, isn't it? And everything they will be providing a alert if you sit continuously over a period of time more than 1 hour, so it will be giving the notification, okay, kindly walk. So in this way, so we can have the real-time monitoring of our health with the help of the RF technology. So in this case, the Bluetooth can be used to access the data from your smart band onto your mobile phones, isn't it? In the same way, any smart appliances, now see here the fridge will be shown, and in this fridge we can have certain what I can say, the screens, okay, and a variety of sensors are interfaced in this particular into the fridge. So they will be showing not only the content stored in the fridge. Take an example, I borrowed or I purchased certain cold drinks, take an example, okay, cold drinks, and I put it into the smart fridge. So that particular fridge will going to take care of what is inside that particular fridge, okay. So whether what is the expiry date, not only that but also it will be observing the expiry date of that particular uh, the cold drink bottle, okay, and immediately inform you whether it is drinkable or not, or will be in a condition to eat or not, everything, okay, if you kept any kind of eatable things into it. So it will be real timely monitoring and showing the content whether it can be eatable or it is not, okay. Everything can be possible, and that will be getting observed onto the screen, or it will be accessible on a mobile phones also automatically, because this particular fridge is directly connected onto the cloud. So whatever the real time data will be sensed by the sensors will be uploaded onto the cloud, isn't it? And lastly, we are dealing about the healthcare. Okay, so the patient monitoring system. Sometimes what happened, the patients are in a ICU sections, in the under the observation section, isn't it? And where nurses will be taking care of it, okay, or that particular fellow, and the doctors will be busy with the, some other kind of work. They will be what you can say, monitor the different patient. So if if we implement certain kinds of smart devices for patient monitoring systems, so automatically now see the real time parameters will be sent on a mobile phone of a doctor, and get the notification what is the current situation of a specific user or a patient, okay. So we can have here wireless body area network, we can have WBAN, okay, how we can send the current parameters of a patient directly onto the screen with the help of different technologies. We'll be talking in details about it in a application case studies in a final unit, how we can develop certain things, what are the requirements, okay, and how we can interface different types of sensors to the your IoT development board, which IoT development board we can select it, so that the processing of data can be easily takes place, okay. So how many sensors that can be interfaced, based on that we can use your development board, okay. It should have that much processing capability. Otherwise, if you are interfacing 100 number of sensors to your Arduino Uno board, so that is not possible because it doesn't have that much amount of capability, isn't it? So based on the processing or sensors interface, we need to select the appropriate development board also. Got it? uh, Up to this, any queries? Are you there, all of you? Write in a chat box. Yes, any query, or are you there? Are you able to okay, is it okay? No issues, no issues till now. Okay, good, good. Now we'll move ahead. Good, means you are there. Or now very popular example, how we can use the IoT technology for emergency services. Now see, in the leftmost portion, the very first product was developed by the Amazon, that is a kind of drone, isn't it? And it will be responsible for distributing the products which the user wanted or purchased it by their doorstep, isn't it? It is a kind of delivery drone, isn't it? So the weight up to 5 pounds. Okay, why the Amazon invented this particular drone? They want to send any specific product at the doorstep of the users, isn't it, within a 30 minutes of time, within a 30 minutes, if you are using a GPS technology, isn't it? If you interface the GPS, the real time monitoring of the location of the user can be tracked, and that particular drone will be now responsible for going to that particular user and provided the particular, what you can say, the consumer contents, isn't it, or the products that that user wanted. Now this is a very popular service used, and the name provided is Amazon Prime Air. Okay, the drone developed in the same way. Can we develop certain kinds of the emergency kind of drones? So generally what happened, if you're having any emergency, healthcare emergency, or take an example of accident happens, okay, in that case what happened, it will take a maximum time to reach the ambulance over there. Okay, so why don't we create certain kinds of emergency drones? So automatically drones will come, and side by side the doctors will be coming over there, or any nearby people or person will take care of it. Okay, so based on that we can able to monitor or survive the life of that particular patient. Okay, so in that particular drone the necessary first aid kit will be there, or certain monitoring equipments will be there, and they will be going to measure the real time parameters of the patient will be having a certain issues with the health. Okay, in case of emergency services, such kind of drones can be made easily nowadays, because we are having varieties of technologies now, and because we are using your mobile phones, smart mobile phones, everything will be available on a tip of your hands, or you are having your palm. Okay, so you can easily search anything on your mobile phones and able to design any kind of project. Anything is possible now, isn't it? Now, these are the some of the very well-known examples. Some of the other examples from our India, or we are dealing with the LG. Now, take an example. If you're aware about the SmartThings, okay, this is the project where LG invented varieties of smart appliances. Take an example. If you're having your LG smart televisions, LG washing machines, LG fridges, okay, then LG air monitoring devices, vacuum cleaners, or the specific devices regarding in the kitchen, laundry, okay, everything they made it a smart one, and the real-time data provided by these devices can be monitored, and not only that, it will also provide the solutions also in the form of diagnostic over internet protocol. I think you might be aware about voice over internet protocol, VoIP, isn't it? Are you aware about VoIP? VoIP? Because currently we are using it. Now we are having a real time virtual connection with you, isn't it? So we are using voice over internet protocol. Whatever my voice is coming, okay, that will be received using your internet protocol, isn't it? The voice over internet protocol. In the same way, can we provide the diagnostic, or can we provide the solution of particular problem real timely, isn't it? Take an example. If I'm using a particular instrument, now take an example of washing machine, okay, and up to certain amount of time that particular washing machine will work, and after that, suppose due to certain issues, that washing machine will show certain kinds of problems to you. Okay, that will be a future kind of thing. Okay, can we predict it earlier? Okay, so if it is not predicted, can we provide the solution afterward immediately if devices are experiencing a problem, isn't it? So what it can be doing, it can be using diagnostic over internet protocol. That particular smart devices will send the problem associated with the devices. Take an example, your spinning machine and your washing machine, that is the motors not work properly. That particular information is broadcasted to the customer care, that is on the cloud. Now from the cloud, the technical persons will directly sort the issues by sending certain codes to your machine. Okay, and with the help of that, your machines can work properly, isn't it? So that is a kind of diagnostic can be done directly or remotely from one destination to the other destination without physical inspection of a device. Okay, virtually we can try to identify the problem and then rectify the solution or rectify the your problems also by providing the solutions. Got it? Now this is one of the application of designed by the LG. Now very popularly everybody is aware about the Google Assistant. Google Assistant in a kind of intelligent device, it will be converting our speech signals into the text, isn't it? And with the help of a Google Cloud, the decisions will be taken out. Now see, if I'm saying, hey Google, can you please play this particular song for me? Now this particular request is going to the cloud, where cloud will going to search the content from their database, and directly it can be now shown or played onto the platform. Okay, so this is an intermediate device. You can use these devices in your final year projects also. You can use your Google Assistant or Alexa or any your mobile phone activities. Okay, that can be a part of your devices or projects, because if you take your mobile phone, okay, in your mobile phone varieties of sensors are available. No need to buy a separate sensors. We are having a gyroscope, we are having an accelerometer, we are having a microphone, we are having a loudspeaker. Varieties of sensors are and actuators are available in your or touch screen, isn't it? So can we use all these devices? AI is also available in your mobile phone, artificial intelligence. So instead of developing your own kind of AI hardware or platform, can we use our mobile phone as one of the device, and it will be taking the decisions or providing the inputs to your program, isn't it? And based on that you can design your projects also. It is some important preliminary input given by your mobile phone to your desktop or your projects, and based on that your project can be work, isn't it? So you can definitely use your mobile phones or any Google Assistant, Alexa, Siri for developing your or designing your applications. Got it? Now, very well known, now we'll talk about varieties of IoT development platforms available in the market, isn't it? So there are varieties of small, what you can say, hardware platforms are available based on their processing capability or their usage, their sizes, okay, and in which application we can use these tools or hardware platforms. So Raspberry Pi is one of the very popular kind of IoT development board. They're very strong because our existing computer. Okay, if I am talking about when I was doing my B or BTech, in that particular days we were using what you can say, uh, the 95 or 2000 OS. Okay, so not 2000, yes, 2000 OS, and the Pentium 1, Pentium 2, Pentium 3, those were the processing capabilities were there. Okay, so and hard drives are also very much bigger in size. Okay, and we are having only 50 GB of hard disk and everything. Okay, not more than that, or 20 GB. Okay, so now see, if I'm talking about the traditional computers and now this particular Raspberry Pi, now it can be easily replaceable. Okay, because varieties of what you can say, the technologies are integrated onto a single chip of just like your smart credit card. Okay, this is just credit card size of platform. Or even if I'm talking about the Raspberry Pi Zero, it is very much smaller in size again. Okay, so here we are having varieties of the services can be available. Now take an example. On this particular Raspberry Pi board, we are having a Bluetooth inbuilt. We can having a Wi-Fi chip over here. Okay, we can connect here 4 different USB devices. So 4 USB ports are given. We can have one LAN port where your device can be connected to the internet using a physical LAN cable. We can having here HDMI port, means anything can be visible on your television. If you are having your normal traditional television, you can create a smart television with the help of simply connecting the Raspberry Pi, and that can be connected to your traditional television. But your traditional television should have the connectivity with the help of at least VGA cable port or the HDMI port. Okay, then and then only you can interface it, otherwise you cannot. Okay, and we are having here 40 GPIO pins, general purpose input output pins, means any device, existing device, we can make it smarter with the help of interfacing Raspberry Pi to that particular device, because Raspberry Pi is a general purpose board where varieties of integration of technologies are there. Bluetooth is there, Wi-Fi is there, isn't it? So here we can interface your cameras, we can have power is provided with the micro USB cable, isn't it? We can have your the 3.55 mm jack. Okay, everything will be available on this particular development board, and at the back side of this particular board we can have here the provision to connect your SD card, isn't it? So depends on a requirement, you can connect here the storage drives, or you can use your SD card as a memories. Okay, where you can install varieties of operating systems required. Okay, every device requires a kind of software to run into it, that is a system software, and OS is a well-known system software, and through which we can install varieties of applications onto it, isn't it? So application softwares are different, system softwares are different. So firmware is a kind of operating system, real-time operating system, RTOS. Okay, so such development boards needed the RTOS systems, okay, where the decisions can be taken. So this particular Raspberry Pi is having a RAM of 1 GB, 2 GB. Currently we are having Raspberry Pi 4 also came into the market. Okay, again it will be having not only the central processing unit, it will be having a very high GPUs also, high graphical processing unit. So for 4 it is you can install your Windows 10 as well, isn't it? Because I have learned many kind of magazines, read many kind of magazines, and come to know that the current Windows operating system 10 can be installed in Raspberry Pi 4. Okay, 4, not in 3, because some of the load issues are there. Now if I want to see in details, as I mentioned earlier, what are the contents are available on this mini Raspberry Pi board, very small. Actually is Raspberry Pi board invented by this Element 14 company, isn't it? And we'll be having here the very first, you're having here 4 USB 2.0 port. Okay, it is not 3.0, it is 2.0. okay, and you can have your LAN port over here, so through which we can connect your internet connectivity physically with the help of LAN cable. 10/100, what it indicates, anybody knows it? Yes, 10/100. Many times this particular number will be represented in front of LAN cable or port. Do you know what is this particular 10 or 100? Let us see how many of you can give the answer of this particular question. Just try it. I think you might be learn in your ITCT project. Data rate, very good. It is regarding data rate. So I think you might be aware about the Ethernet evolution, isn't it? 10 base 5, 10 base T, okay, 100 base 5, 100 base TX, FX. Okay, so it indicates the data rate through which the cable or that particular port can be able to exchange the data. So this particular board is having a NIC card inbuilt, that is network interface card. Okay, means your cable or outer connection can be connected with the help of this LAN port. So 10 Mbps, or it can be supported up to 100 Mbps of data. So real-time data, it is not a speed of internet, it is a speed of intranet, that is the local networking. If I share 2 computers or 2 Raspberry Pis, they can handle the data up to 100 Mbps of speed. Okay, so that it indicates the speed of that particular data. Now next, as I mentioned, there is a one small port will be there, 3.5 mm jack for it will be also considered as your composite video and audio output jack. If you're having your small DVD players, or we can have on your mobile televisions the yellow, red, and white kind of ports, isn't it? So yellow indicates is the video, sending of video and reception of video. Red and white indicates is the left hand sound and right hand sound. Okay, so these three cables can be used here also. So the data can be visible on your desktop or any smart televisions or normal television with the help of this particular video audio port jack. We can have here the CSI camera interface also. Okay, we can have your small, if you observed or surveyed varieties of sensors, or specifically I'm talking about camera is a visionary sensor. So we can here connect the cable or the PCI cable of your cameras over here and interface with your Raspberry Pi, and you can take real-time monitoring of the video and the images onto it. This would be considered as an HDMI, high definition multimedia interface port, okay, through which very high definition of data can be exchanged, and that can be observed onto your televisions or your the devices, display devices. Here, this small port will be indicating is the micro USB port, just like your mobile phones having for charging. So we can power up the Raspberry Pi with the help of this particular small micro USB port. Okay, and that can be handled up to the current of 2.5 amperes. Okay, so it's a very good amount of current required to work onto this particular platform. We can have DSI display ports. We can connect other displays also with the help of this particular. Take an example. I need to interface LCD displays, isn't it? Display just you are using in your mini project. Okay, so all these displays I can interface here with the help of this particular port cable. We can have a provision to connect micro SD card. Okay, so micro SD card, but that card should be because how many of you are aware about the SD cards? Are you aware about SD card? SD stands for? Because if you take an example, if you do the literature survey of SD card, there are varieties of SD cards are available in the market based on the data rates. Are you aware about it? Because we are having SD card in a black colors. We are having SD card with the colored kind of SD cards also. Samsung, okay, made up by Samsung, then Tronics, something that. Okay, so the class 4 kind of thing, class 10 kind of things. Are you aware about it? Class 4 SD cards, class 10 SD cards. So if you are using class 4 SD card, that cannot be capable of reading the content, and means that is a data rate through which the data can be stored on your SD card, and that can be read out from the data card. So it should not be smaller one. Always go for at least minimum class 10 of SD card for your Raspberry Pi to work properly. You can work on a class 4 as well, but the speed will be very much slower. Okay, so it will always, if you open a specific application, it will take or took a maximum amount of time to open it or to work it. Okay, so it's preferable, it's preferred to select here, yes, the class 10 of SD card always. Okay, now that will be capable of exchanging the maximum data rate. Okay, next is on this board you can have the Bluetooth 4.1 and Wi-Fi IEEE, not 2.11. So you can connect varieties of devices wirelessly with the help of Bluetooth technology or with the help of Wi-Fi technology. So that is again one of the popular reason why this Raspberry Pi is very much popular nowadays, isn't it? Because of the connectivity issues. Okay, we are getting very good connectivities technologies incorporated onto this particular development board. The integration, heterogeneity I am talking about. The various devices with the heterogeneity, the technologies can be connected. I can connect varieties of device with the help of Bluetooth, or I can go for Wi-Fi also, isn't it? So currently, I think Bluetooth 5 was there, but that is not still available on Raspberry Pi. Do you know what is the importance of Raspberry, the Bluetooth 5? What it can be done? What is the advancement done in Bluetooth 5? Anybody knows it? Or you can do the literature survey of it. What are the specifications of Bluetooth 5 technology currently available in the market? And we'll be getting that very soon on latest our mobile phones. Next one, and very important, regarding the CPU and the GPU available on a Raspberry Pi. Okay, so it's developed by the Broadcom company. BCM 2837 is the main the name of this particular chip used in a Raspberry Pi, and which is having a 64-bit is this particular Raspberry Pi 64-bit quad core CPU. Four cores are there. Okay, and with the speed is the 1.2 gigahertz and 1 GB of RAM for the Raspberry Pi 3B. But for 4, we'll be getting advancement in this particular speed as well as the RAM. Okay, and I think the processor is a 64-bit also. Below this particular CPU, we can have your GPU, graphical processing unit, and real-timely data can be processed. High data or the huge amount of data can be processed with the help of this GPU technology. Now these are the very simple kind of introduction about Raspberry Pi, what it consists of, but you should know the features. Yes, secure digital card. Yes, very good. Many of you have given the long form of SD, the secure digital class SD cards. SD. Now see, there are varieties of cards are there. So based on your the data rates provided, okay, or the speed that is provided to exchange the data from the memory and to the memory. Now you can compare it. I have given some very simple kind of comparative between the Raspberry Pi 3 Model B, Raspberry Pi 2 Model B, and simply Raspberry Pi B Plus. Now there are varieties of changes are there. Specifically, I am talking about the processor speed. I am highlighting it. Now processing speed of 3B is 1.2 gigahertz. For 2 it is 900 megahertz, and for normal Raspberry Pi B Plus it is only 700 megahertz. Okay, now next one I am talking about the GPU, that is graphical processing capability. There's operating at 400 megahertz, here 250 megahertz, and here the same 250 megahertz. Next one, the maximum power drawn, that is why I'm talking about the current and the voltage. Now here it will be 2.5 amperes, and for remaining one it is only 1.8. Then we can have the Wi-Fi and Bluetooth, that is inbuilt in 3B plus. Okay, but there is no Wi-Fi and Bluetooth available in your normal 2 and B plus. Okay, rest of the things are same by except only these things. Okay, now here we can have only one small major change, and so 512 MB of SD RAM. Here now it is upgraded to 1 GB, and now in Raspberry Pi 4 it will be about 2 GB or 4 GB. It depends on our requirement. We cannot change it, but it is a fixed one. But based on our kind of application, we can use them. There are varieties of operating systems are available. These are the open source operating systems. You can install it, you can download it from raspbian.org, and you can simply install it onto the SD card. There are varieties of tools are available, SD formatter or image, how you can extract the image onto the SD card and simply plug into your display boards, connect the keyboards and mouse to your Raspberry Pi, and now you are ready to work onto the development. Okay, noobs are very much popular. Raspbian is very much popular. Are you aware about noobs? What is noob stands for? Long form. Yes, anybody knows it? Noobs stands for. Yes, you can write it here. Noobs, because we are having one specific why the noob name is given. That is regarding new out of box thinking kind of thing. If you want to develop certain things, when you want to go beyond it, yes, new out of box kind of things, isn't it? So that is why it is, as it is open source, we can think in a wide way. Okay, that is out of box thinking, we can say that. That is why the name is given. In the same way, we can have your Ubuntu Mate system, Snappy Ubuntu Core, Windows 10 also for IoT only. It's a smaller kind of operating system is there for real timely operating. Those who wants to work in a Windows, they don't want to work in a Linux, they can have this particular support from the Windows. OSMC is very popularly used. Are you aware about OSMC? It's the open source media center. You can create your own kind of media center. You can store your varieties of videos, audios, movies, and you can real timely stream it just like your YouTube. Or you can install the OSMC in your Raspberry Pi, and now you can ready to create your ordinary television into the smart television, isn't it? We can send any data real timely. That is just like a screencasting, miracast or screencast. Your mobile phone videos, audios, images can be broadcasted wirelessly onto your television, smart television, with the help of this OSMC operating system. We can have Libre Electric, then we can have PineNet, Risk OS, then the weather station. There are varieties of, you can simply visit to the raspberry.org and you can download it, install it, and now you can ready try it only. Okay, try to install it and work according to it. Okay, I think these are the operating systems. There are varieties of boards are available. I think I'll be just showing the content. You can read it, the details on the cloud. We can have the Arduino boards, Arduino Uno, Nano, Mega, Mini. There are varieties of versions are available. Now see, there are varieties of sizes are there. LilyPad for smartwatches and all these things. I've given the difference also. The Beagle board, very popularly used. Intel Edison board, Intel Galileo board. The difference is given. The WAND board is very popularly in very high processing capability board, WAND board. Then Ordite board specifically for those who are game lovers. Okay, the video games can be designed with the help of this Ordite board. Udo board is a very highly just like your CPU motherboard, isn't it? We can have varieties of motherboards in which very latest kind of processors are used. Now see here, the CPU Intel Pentium 2.6 gigahertz up to, okay, and will be having a RAM of 8 GB, and the graphics cards also, means high computational power boards are there. We can use Udo boards as well. We can have the Internet of Nano Things. We are going to minimize the size of each and every IoT development board so that it will be using a less amount of power. Less amount of power can be consumed, and the processing capability will not work. Yes, then we can have varieties of sensors. We'll be going to discuss the sensors in your second unit. The working principle of the sensors and the actuators, and the different cloud platforms. That is a Google Cloud, AWS Cloud, Microsoft Azure, Arctic Cloud by Samsung, UB.Dots, Xively from Logmein, Smartphone, ThingSpeak, IFDDD. Then we can have ThingSpeak.com. Okay, we can have IFDDD, then Adafruit, then your Blink Cloud. There are varieties of clouds are there. Simply you can do the literature survey. You'll be getting lots of clouds. So that again, that IBM Watson, very good. Then you need to do this particular what you can say, the homework regarding, you find open source cloud platforms and what you can say, the companies they will be using it, enterprise kind of that is a private kind of clouds. Okay, you can do that part at your as a homework.